Safety in the academic chemistry laboratory is the responsibility of everyone who works in the lab, including faculty members and students. This presentation considers the type of eye protection that are acceptable and appropriate in the laboratory setting. What's the worst that could happen if you don't use eye protection in the lab? After all, you're careful handling chemicals, and you aren't working with really hazardous materials. Just think for a moment about how your eyes feel if you swim in a heavily chlorinated pool without goggles, or if you get salt water in your eyes. Now look at what could happen in the lab if someone jostles your arm and you're not wearing eye protection. Luckily, that's a mannequin head splashed with dyed buttermilk, but it could be you splashed with hydrochloric acid. We hope the previous photo convinced you of the need for eye protection in the chemistry lab. Several types of eye protection are available, but they serve different functions. Let's compare the effectiveness of prescription glasses, visitor's glasses, and chemical splash goggles. Some students say they don't need to wear additional eye protection because they're wearing prescription eyeglasses. Look at what could happen if chemicals were splashed on a student who's wearing prescription glasses. Prescription glasses are required to meet standards set by the U.S. Food and Drug Administration for impact resistance, but they don't offer adequate protection from splashes. Liquids can drip down from the forehead or get behind the glasses from the side. Remember that not all splashes are directly into the face or even from your neighbor. Visitor's glasses have a splash guard above the lenses and possibly on the sides as well, so they offer more protection than prescription glasses. Let's see how they function in the lab. As you can see, visitor's glasses have slightly more protection than prescription glasses. However, the splash guard does not conform to the face, and there is no real protection against splashes from the side. The very name of these glasses confirms the fact that they are not acceptable for anyone working in the lab. Only the chemical splash goggle, more commonly called safety goggle, provides full splash and impact protection for the eyes. These goggles meet both the American National Standards Institute and Occupational Safety and Health Administration personal protective equipment standards. The chemical splash goggles enclose the face completely around the eyes, giving full protection to the eyes, but not the face itself, from splash liquids and solids. Safety goggles come in several sizes and colors. The adjustable elastic strap allows them to be fitted closely to an individual's face. Most goggles are vented, and the venting plug should never be removed. Some goggles are not vented, and these are particularly appropriate if soft contact lenses are worn or if there is a greater likelihood of chemical splashes. Not all goggles are appropriate. Goggles or glasses, such as those used for sports and in the shop, do not meet the standards for work in the laboratory and should not be used. We've already seen that prescription glasses don't offer adequate protection from chemical splashes, but obviously people may need to wear them in the lab to see correctly. Chemical splash goggles are designed to fit over prescription glasses and must always be used with contact lenses to provide adequate protection. Although no one should be working in a lab where the concentration of fumes is sufficient to affect their eyes, individuals may be more sensitive to vapors. Soft contact lenses are hydrophilic and may absorb certain volatile chemicals passing through the vents in the safety goggles and put them in contact with the eyes. If that could be an issue, consider wearing unvented goggles. They will trap the heat more than vented goggles, but they would help to keep out the vapors. You have probably all been told in each chemistry course you've taken that everyone in the lab should wear goggles at all times. even when you're not performing a chemical operation. The reality is that many students still try to avoid wearing goggles and have to be constantly reminded. Why is this true? Students and faculty and working chemists generally offer 3 reasons for not wearing goggles. 1, they don't fit and are uncomfortable. 2, they're too hot. And 3, they fog up. The first step in having properly fitting goggles is to pick an appropriate size for your face, since goggles come in different sizes. If you have problems with the fit of standard goggles at your laboratory, check with your instructor to see if smaller or larger goggles are available. After you have the proper size goggles, adjust the fit using the elastic strap to tighten or loosen them. The goggles should fit snugly, without sliding on the face or cutting into it. If the goggles leave marks on your face after they are removed, they're too snug. If they move around too freely, they're too loose. If you find the goggles make you too hot, some types of goggles allow you to adjust the cap on the vents to allow more airflow. Raising the cap as shown will allow splashes to get behind the goggles and reduce the level of eye protection. No adjustment is possible, of course, with unvented goggles or even with all types of vented goggles. As a consequence of the possible heat buildup behind the goggles, the lenses sometimes fog up. Skiers have a trick they use on their goggles which can be of value here. Rub a little soap solution on the inside of the goggles and wipe them dry. A small amount of residual soap will prevent fogging without leaving a visible residue on the lens which could distort your vision. Sometimes protecting your eyes isn't enough, because your face and body may also be exposed to hazardous materials. This could happen when work is done at a reduced pressure or when there is a potential for dynamic reactions, implosions, explosions, vigorous splashing in the reaction vessel, or severe chemical burns, for example from strong acids and bases. Your lab directions and instructor should warn you of these possibilities, but you should also take responsibility for determining if any of these situations might arise. If any of these hazards is possible, reaction should be carried out in a fume hood, with protection provided by either a vertical or horizontal sash. Fume hoods have a sash that may be vertically lowered or horizontally closed. Putting apparatus in the fume hood and lowering or closing the sash on the hood will give additional protection to your face and body, as well as protection against potentially hazardous fumes. You still have to wear your goggles. If for some reason potentially hazardous work is not done in the fume hood, you should use a bench shield that is wide enough and long enough to protect your neck and ears. Make sure that the bench shield is properly placed and sturdy enough not to be easily tipped over. It does not, of course, provide any protection against fumes and only protects the person working in front of the shield. Goggles must be worn at all times. A face shield, if available, will protect your face and neck and allow you to move freely around the apparatus. A face shield will not protect your upper body as a hood sash or bench shield would. You still need the eye protection of the splash goggles. Let's summarize the key points about eye protection. Only chemical splash or safety goggles provide adequate eye protection. Prescription glasses and visitor's glasses are not acceptable. Everyone in the lab, students, instructors, and visitors, should wear safety goggles at all times when chemical operations are being conducted. This is true even if the individual is not carrying out an operation. If you are doing paperwork and don't want to wear goggles, ask your instructor if you can work outside of the lab or in an isolated section of the lab. If you are wearing prescription glasses or contact lenses, wear goggles over them. This is particularly important in the case of contact lenses, which can trap chemicals and keep them in contact with the eyes. Use bench or face shields when needed to protect the neck and ears. close the sash of the fume hood for additional protection. Although proper eye protection should prevent the possibility of liquids or solids getting into your eyes, you should be aware of what to do in case of an unforeseen accident. The first step is to familiarize yourself with the location and type of eye wash units in your laboratory. Eye wash units may be found on a sink, either in a stationary or handheld arrangement. They may also be combined with safety showers in a corner of the laboratory or near a doorway. If you get a chemical splash on your face, quickly and thoroughly wash your face to remove any splash chemicals and avoid further damage. Then immediately remove your goggles and use the eye wash unit. Don't waste time calling for help. Let someone else get the instructor while you start flushing out your eyes. Correct treatment of the eyes requires that the eye be kept wide open and be flushed for at least 15 minutes, preferably with tepid water. Very cold water will numb the eye quickly and you may be tempted to stop the flushing too early. Don't! Hold your own eyelid open or have someone assist you and flush for a full 15 minutes while someone else calls on medical assistance. Emergency eye wash bottles typically have small volumes of water and a low flow rate. They are not sufficient for flushing the eye, and they may also damage the eye further because of a bacterial buildup. Contact lenses are often worn as an alternative to prescription glasses. Although they were at one time forbidden in the laboratory, they are now allowed as long as chemical splash goggles are also worn. In case of an accident, however, they may adhere more tightly to the eyeball as tears, a natural lubricant form, and the lenses must be removed for proper flushing. They could also trap particles or liquids and keep them in contact with the eye. Make sure you tell the instructor that you are wearing lenses and remove them before flushing. The last warning about eye protection is that no one should ever attempt to neutralize chemicals splashed in the eye. Only water should be used. Get medical attention immediately. Make sure the examining doctor is aware of the chemicals involved in the splash.